You might be wondering why, for these complex numbers, we're taking the time to learn how to express them as in the polar version and in the exponential version, and that's because oftentimes you will have two complex numbers and you want to multiply them. Or you have two complex numbers and you want to divide them. If you try and do these operations and both of these complex numbers are in the rectangular form, it can get very messy sometimes. But as it turns out, what is nice is if you ever multiply or divide two complex numbers, but these numbers are either in the polar form or the exponential form, it becomes a lot easier. And a matter of fact, in my opinion, to do these kinds of things in the exponential form is the best way to go. So here's what's going to happen. In a minute, we're going to do a problem where we're given two complex numbers in rectangular form. First thing I'm going to do is convert them each to the exponential form, and then they become very easy. And I'll just show you quickly how it works. So in exponential form, there's this complex number, and in exponential form, we'll have this. Here's what's great. When the two complex numbers are in exponential form, if I want to multiply them, all you do is you multiply the two R values, and then for the exponential, you simply add the two angles together. Multiplication and addition, boom, you're done. If you want to divide, you divide the two R values, and in this case then you subtract the two angles. This kind of thing is a lot easier than trying to do these operations with your complex numbers in rectangular form. So let's do an example. Now when you have homework in the book, what they like to call the two vectors, or the two complex numbers z and w. So we'll call z 2 plus 2i, and then we have w is square root of 3 minus I. And they want to multiply these together and then also divide them. Best way to do this is to take each of these complex numbers and first convert them into I'm going to convert them into the exponential form. So I need to get R and theta for each of these. So let's just go over here to the side and do that. So for the z complex number, we've done this 2 squared is 4, plus 2 squared is 4, square root of 8 simplified. So z, the R is 2, square root of 2. Now, let's go find the angle. Now this one we've done before, y over x, 2 over 2. This is obviously in the first quadrant. What's the angle where the tangent is going to be 1? Well, that's where sine and cosine are the same, and that happens at pi over 4. So in exponential form, this complex number z is 2 square root of 2 times z to the I times pi over 4. For the w complex number, r square root of 3 squared is just 3, negative 1 squared is 1, square root of 4 is 2, now the angle is the inverse tangent of negative 1 over square root of 3. We've actually done this before in prior videos. What we did there is to say what we really want to do is to know what's the angle where the tangent is negative 1 over square root of 3. And we could think of tangent as sine over cosine. If you think about it, this is going to happen. We are in X and Y. We're in quadrant 4 here. So we want the angle in quadrant 4. What we want is the sine is 1/2. The cosine is square root of 3 over 2. And that happens when theta is so the angle for complex number W is 11 over 6. Or 11 pi over 6. So now, if we want to multiply these, you simply multiply the r's. 2 square root of 2 times 2 is 4 square root of 2. And then you add, in this case you're going to add pi over 4 and 11 pi over 6. Let me go up here and do it where I've got some room. It's like adding two fractions. I have to get a common denominator, which is going to be 12. This is going to be 3 pi over 12 plus 22 pi over 12. Now, it's a little tricky because you think you're done and you want to plug in 25 pi over 12, but actually in the problem they want the angle to be between 0 and 2 pi. And this is larger than 2 pi, because 2 pi actually would equal 24 pi over 12. So hopefully you can see that this exceeds 24 pi over 12 by pi over 12. So this is like coterminal angles. So 25 pi over 12 is the same thing as pi over 12. I mean, just to be clear, 25 pi over 12 is probably right about here. This is 25 pi over 12. We need to find this angle here. That angle there is pi over 12. So actually, in the answer, you want pi over 12. Now, to divide them, 2 square root of 2 over 2, which that's going to cancel out square root of 2. And then we're going to subtract. So now I'm going to subtract pi over 4 minus 11 pi over 6. So once again, we're going to have to do, I think I'll have room down here to do it. Let's see what happens here. So this is going to be 3 pi over 12 minus 22 pi over 6 minus 19, over 12, minus 19 pi over 12. Once again, it's like we have to find a coterminal angle. Easiest way to do that is just to add 2 pi. This goes back to what we learned at the beginning of the class. So 2 pi is 24 pi over 12. Looks like 5 pi over 12. So this is going to be square root of 2 e, this is I here, I to the 5 pi over 12. So sometimes angles are still messy, but here's the division, here's a multiplication. Now the next two problems are going to be easier. You know why? Because the initial problems, this next one, they give us the problem where the complex numbers are already in a polar equation. So 3 cosine of pi over 9 plus I sine of pi over 9. And the z is 5 cosine 5 pi over 9 plus I sine 5 pi over 9. Just to make it even easier, let's just rewrite these. I just like to use the exponential equation. 3e to the I pi over 9. 5e to the I 5 pi over 9. So if you multiply them, you multiply the two r's, and you add these, that's nice, same denominator, pi over 9 plus 6 pi over 9, which is actually 2 pi over 3. Wow. And then if I want to divide them, 3 divided by 5, I keep forgetting the I here. And then we subtract pi over 9 minus 5 pi over 9. So once again, we don't want to leave this negative angle here. So basically we have to find a coterminal angle. So to find coterminal angles, I add 2 pi to this. Well, 2 pi is 18 pi over 9. 14 pi over 9. Now I'll do this once, but it's really, so they want the answers in exponential and also polar forms. Well, we've done this before, right? Polar forms just means you write the r, you put the cosine of the angle 2 pi over 3 plus I sine 2 pi over 3, right? And if you want to do the division, it's simply 3/5. Here's your angle, 14 pi over 9, cosine 14 pi over 9, plus I times sine 14 pi over 9. So that wasn't too bad. And then we'll just do one more real quick. This one also. This time they give you the complex numbers in, I can't even read my own writing. I might have to, let me look in the book where this problem was. Looks like e to the I 13 over 18. 13 pi over 18. And then z was 4 e to the I 3 pi over 2. But this is pretty straightforward, right? 3 times 4 is 12. So 13 over 18 plus 3 pi over 2. The denominator of 18, 9, that's 27. All right, let's just do this. Plus 3 pi over 2. Common denominator, this is multiplied 9, so 27 pi over 18. So 30 pi over 18, which reduces down to, if I divide by 6, 5 pi over 3. I'm looking to make sure I didn't mess up on this. And it looks like I did. Let me see if I can find my mistake real quick. I don't want to have to start this video again. So let me make sure. I apologize. 13 pi over 18. Oh, yep. And then 3 pi over 2. So when you multiply this by 9, 27. So that's, oh, see, I can't add. That's 40. Wow. So 40 pi over 18 reduces down to 20 pi over 9. And unfortunately, that's going to be larger than, that's outside of 2 pi. So I'll subtract 18 pi over 9 to get it inside of 0 to 2 pi, and that's 2 pi over 9, which is the answer I was expecting. So four times 3 e to the I 2 pi over 9. Now dividing, so even as teachers, try to be careful with your math. It gets all of us. So 3/4, and now I'm going to have 13 pi over 18 minus 3 pi over 2. So now let's see if I can do this correctly. 13 pi over 18. So 3 pi over 2, denominator 18 is going to be 27 pi over 18. Negative 14 pi over 18, which reduces down to negative 7 pi over 9. Once again, it's not between 0 and 2 pi. Coterminal angle. I'm going to add 2 pi, which is 18 pi over 9. That should be 11 pi over 9. And then in this case, that is correct. E to the I, 11 pi over 9. All right, as long as you're careful with your math, you should be able to get these correct answers.